What is the direction of the acceleration in circular motion? A simple one-word answer to this question would be centripetal. That's why we call it centripetal acceleration, which means towards the center. But let's look at that with some pictures here in the answer. So it says towards the center at right angles to the tangential velocity. So in this picture, I've got some kind of car or something here. It's moving in a circle and at three different positions. It's showing a tangential velocity. Again, tangential, in other words, the directions here are tangent to the circle that this car is moving in. But how can we interpret or use that to figure out like the direction of acceleration? Well, recall, again, acceleration is equal to change in velocity over time, but really change in velocity vector. So let's look at, we're going to look at kind of like, think of this maybe being like the initial velocity, final velocity. There's also kind of a middle velocity here. So maybe we're trying to answer like what should be the acceleration right there. But we're going to use these two that kind of happened before and after to answer that question. So those are those two vectors right there. This upper one is kind of that initial velocity vector. This is that final velocity vector. So the change in velocity should be final minus initial. Or another way of looking at that is you could say, well, the initial velocity plus the change in velocity should give me the final velocity. So whatever vector added to this one would be the delta v vector in the definition of acceleration. So that's going to, oops, hang on, I jumped 2 slides there. That's going to come in next if I didn't accidentally hit the button the wrong way. There it is. There's that change in velocity. And again, you can see that head to tail vector addition. Initial velocity plus the change gives you the final, and that's the vector that the acceleration is going to be based on. So the conclusion we can draw is that therefore the acceleration vector for this part of the picture must point towards the center and therefore at right angles to that tangential velocity, which again is what is described up here. Something that, just to avoid a certain pitfall, is to recognize that if I had done that analysis maybe with like another cart down here or something like that for this one, I would have gotten an acceleration that points towards the center there, but it wouldn't point in the same direction as this one because things have adjusted since then. So really at each point along this motion, there is always an acceleration vector that points towards the center, but its direction is adjusting. So if somebody said, oh, is this constant acceleration in circular motion? It's constant magnitude, but not constant direction, because that is continuously adjusting as the circular motion progresses.